Thanks, Hannah, and sorry it dropped out. First of all, I also want to acknowledge I'm coming to you from Wurundjeri country, the Wurundjeri people of the Kulin Nation, who were themselves great astronomers, and also just acknowledge Joe Parr and all the preparation that's gone into this wonderful conference. I wanted to share a few things with you today. First of all, Australia will join with the US yet again, shoulder to shoulder, for the return to the moon and on to Mars. So I want to share a little bit about that program with the Australian Space Agency, give you a little introduction to the Space Agency and how we're going to run that program, and then take a bit of a short journey to Moon and Mars, and look at the challenges if we're going to undertake missions of longer duration, how we might use the resources on the Moon or on Mars, and just look a little bit at that technology. There's been some pretty important developments as well at the end of last year in 2020, particularly in relation to water on Moon and Mars. So I want to share just the latest of that science with you. And then as a bit of a teaser at the end, and because we're geologists, I just want to share some of the really exciting plans to explore the ocean world of Europa, one of Jupiter's moons. So let me introduce the agency, formed really just over 2 years ago, and the purpose is to completely transform and grow our space industry sector. We want to broaden the economy, just create jobs for young Australians to be able to enter the sector that really haven't been available, and of course we can't do that without the partnerships that we have around the world, and really change as well what happens in everyday life, not just out in space. In terms of Moon to Mars, the Prime Minister Morrison announced $150 million in October of 2019 for Australia to, as I said, stand again at the shoulder of the US. We were right there in the 1960s with the Apollo missions, and so this is really a chance to be part of some pretty exciting developments. In terms of how we're going to run that program, and it's already started, so 3 areas. First, we'll be supporting companies and researchers to get into the supply chain for the Moon to Mars program. So really trying to kickstart our industry with those partnerships and de-risk those partnerships. Then, it doesn't really count until you can get something on orbit. So we've got to demonstrate a program which is focused on getting Australian technology on orbit, and then we can show the world what we can do. So a major program there. And then the Trailblazer program, still kind of working through that under wraps at the moment, but we're working with NASA on a really significant part of the mission that Australia will contribute and have Australian flag. So that's just a little bit about it. You'll hear more about that as we start to release the outcomes of supply chain and demonstrator programs and some of those missions and projects that will emanate from this program. And then during the year, as we progress the discussions with NASA, you'll hear more about the Trailblazer program and what that will actually involve. So if we're going to undertake these missions of longer duration, it all starts with having the funding to be able to sort of fund missions of longer duration. But of course, what's important here is you need to be able to have a rocket that can take the sort of capacity that we will need to the moon. So NASA has been working with Boeing and Aerojet on what's called the Space Launch System, called the SLS, on what will be the most powerful rocket that we have seen to date. And what's going to be amazing is that you'll be able to feel the liftoff of this. If you're 3 kilometers away, you'll be able to feel that kind of roar of vibration. You'll feel the vibration right in your bones. It's going to be extraordinary. 95 meters high, payloads of 26 tons. And just to give you a feel for how that's progressing, in January 16th, or just last month, the rocket had its first hot fire. So that's progressing for potential launch later this year. The next thing you're going to need is the spacecraft to be able to carry the astronauts, and this is the Orion spacecraft. Lockheed Martin, one of the primes there, doing the early assembly. and this will carry up to 4 astronauts. It's just, again, just a few weeks ago, so January the 14th, the assembly, the components, the subsystems have all been complete, and here it is being moved from the Neil Armstrong building and heading off now to get its fuel loaded and to get ready for launch later this year. So some really exciting developments in the Moon to Mars program, literally in the last few weeks. I kind of want to share with you what's happening in real time. The SLS will carry Orion, shown there at the bottom there, and it will carry it to what you can see there in the right-hand side of the screen is Gateway. So this is a sort of bigger version, if you like, of the International Space Station that will act as a staging point, particularly to go to Mars. Some of the plans for Gateway still up in the air. We're just changing the administration to the Biden administration, and so some of the timelines still uncertain around Gateway, etc. But I'll sort of put that caveat on much of the timelines that we will talk about. So gives you a sense of it. In terms of what going back to the moon is going to look like, NASA's still talking about being on the lunar surface by 2024, perhaps 2026, so a little bit of flexibility there, but even the latest announcement still saying 2024. And that will go in stages. So obviously the first stage is really going to test the spacecraft, a very important test the spacecraft. You know, Orion sitting on SLS, no crew at this point, and that should happen in 2021. And then SLS and Orion will do with a crew, will do an orbit of the moon and return. So no landing, just making sure that all of the orbit and the human element is working well for the astronauts. They'll also go further than any human has gone, as they do a full orbit and a long orbit around the back of the moon. So that will be pretty exciting as well. And then there'll be a series of support missions to kind of build out Gateway. So putting on the solar electric propulsion, which Maxar will do, doing the habitation module, which Northrop Grumman are doing. So kind of build out Gateway, and you can see that at the north. And then what's pretty exciting is Artemis III, right at the end there will be the crewed mission, first woman, next man onto the lunar surface, and they plan to land in the south pole of the moon. And I have to say of the moon, because I was speaking with one of our government ministers, and I kept mentioning the South Pole. She goes, "Why would they want to go to Antarctica?" I said, "No, not our South Pole of the moon." So I'm very careful now when I use that. Obviously, one of the most important things will be water, finding, extracting water, and testing all of the equipment and challenges that will be faced with Mars. And this is really the next stage. So phase 2, building out those capabilities, living and working on the surface of the moon, which is extraordinary in itself. And this is really the phase that Australia will be looking to join, and where we're having our discussions. You'll see on the slide there the CLPS, the CLIPS opportunities. This is opportunities for commercial companies to demonstrate some of the capability that you'll see. So that's what we're joining, and of course it's pretty exciting when you think about living and working off our planet. And then as we go further to Mars, which will be beyond 2030, this is really the opportunity perhaps to even discover signs of life on Mars and learn more about Mars. So, as a geologist, you always start with a map. So we better get more familiar with the moon and Mars. This is the delightful brand new topographic maps of the moon and Mars, which have been released. And the white area there, elevated, the blue, purpley blue, the deepest areas, and you'd be familiar with those, the Mare areas. But what we're not as familiar, you often see pictures of the moon is quite flat, but actually there's a lot of topography, and from white to purple on that scale is about 13 kilometers of elevation. And just to put that in perspective, if you went from the bottom of the Mariana Trench up to the top of Everest on Earth, that's about 18.8 kilometers. So there's some serious topography there. In some of these craters, you certainly won't be driving the moon buggy down their slopes. So, and I just pointed out there that the South Pole Aitken Basin, which is an important area for the Artemis missions in terms of landing and discovering. And we'll talk about why that is next. Part of that reason is water. So when I went to school and during the Apollo missions, we really considered the moon to be dry, and we now know that not to be the case. So the LADEE mission in 2013 and 14, which orbited the moon, discovered water signature, but it was periodic, and you can see in that graph there in the top right, they got this kind of periodic evidence of water. And very confusing for everyone until they realized that they coincided with meteorite showers. And then they started to surmise and postulate that perhaps the water was buried deep and the meteorites were releasing it. What was really exciting in October of this year was that water was confirmed on the moon, and that was done using the Sophia instrument, which is an infrared instrument, and it is on a Boeing 747 that goes up to the stratosphere, and it detected the unique signature for water and confirmed that the water was in these deep shadowed areas that don't see sunlight at all. They are really cold, so minus 175 to minus 200 degrees Celsius, these permanent shallowed areas. Not sure exactly how the water is held there, so this will be interesting to learn when we return to the moon. At the moment, the postulated that it's either in glass or it sits in the voids of the grains. And this is the work that we're seeing of Casey Hannibal and Paul Hain, the principal authors of some of this work in October 2020. So moving on to Mars, and as Zed's saying, you have to be very familiar with the geography and geology and maps of both Moon and Mars over the next little while. So this is just a start of that. What really stands out in this image are the big mountains there on the left, those sort of three mountains, and the fourth one further off to the northwest as you look at it. These are the Tarsus Montes, and they were discovered in 1971 by the Mariner 9. They're some of the largest features in the solar system. And the fourth one there up there, the one you can see at the top, that's Olympus Mons, and it's 22 kilometers high. So to put that in perspective, it's twice the height of the largest volcano on Earth. So there's some pretty big things. But anyway, we're looking for water, so let me get back to the task here. But I couldn't resist giving you a nice topo map there. So water on Mars, and the first evidence of water was this area called the crater or Serenium Fossae. Fossae just means a sort of major gorge or canyon. And they noticed that you can see in blue there, coming out of one of the layers, you can see these kind of blue lines coming out. And they noticed that there was the release of these, postulated were brines, and they were seasonal. And that's what was the clue, is they weren't flowing all the time. So first they thought they were brines, and then they said, well, maybe they're not brines. So maybe they're just loose material, loose, dry material that flows seasonally. But now gone back and really re-looked at this, and still the consensus is that these really are the release of subsurface brines. So pretty exciting. And then what was also confirmed in October 2020, some really encouraging news. And Sebastian Loro and a team of mainly Italians, but international team, which had Gabriella Capraelli from the University of Southern Queensland, so some Australian contribution here. They had another look at the radar information, and what they confirmed was patchwork of really salty lakes that sit below the surface of the South polar region layered deposits on Mars, and this was really exciting. The authors are postulating, we haven't confirmed this obviously, but that it's hypersaline perchlorate brine, so an interesting liquid in itself. So lots to explore on both the Moon and Mars. One of the things that will be important is if we do undertake these missions of longer duration, that we will need to use the resources. So I just wanted to touch base here just a little bit on some of the first experiments here. I love this little one. This is Moxie, and Moxie is on the Perseverance rover as part of Mars 2020 mission. Mars 2020 mission was launched in July last year. And this little Moxie unit is kind of cute. It's about the size of a car battery, so it sits on the rover, and it takes advantage of the fact that the Mars atmosphere is 95% CO2. So Mars doesn't have a lot of atmosphere. Most of it's been stripped away by the solar wind, but what it does have is mostly composed of CO2. So here's an opportunity to take the CO2 and use it as a mechanism for generating an oxygen plant for the astronauts, as an oxidizer for rocket fuel. So lots of opportunities there. And so Moxie is basically a sort of ceramic stack. It uses electrolysis, and around 800 degrees Celsius, it converts the CO2 to oxygen, which is purified, and then it releases carbon monoxide onto the Martian atmosphere. Now it will, they're aiming to produce around 32 to 40 grams an hour of this. 6 to 10 grams an hour of this. So this will be an experiment, and it will cycle on and off using the power system on the rover, which is not a lot. It's like 110 kilowatts of power. So it's a good power system, but it's not a lot of power. So it will cycle on and off from the power system and produce about 6 to 10 grams. An astronaut needs about 30 to 40 grams an hour. So you can see this is an experimental stage, but a really neat piece of equipment. On the Moon, much more earlier plans, and so we're not sure yet whether we can separate the oxygen yet from the water, and how we would do that, but already looking at something which has more flexibility to do anywhere on the Moon, which is to use the regolith itself and extract the oxygen from the minerals, from the oxides, from the material, some of which not dissimilar to what we see here on Earth. And effectively, this is really just a molten salt electrolysis, which we would do on Earth for metal production. And if you're using, ceramic anodes, then anodes, electrodes, ceramic electrodes, then you're going to get oxygen. So when we produce aluminium, for example, the moment we use a carbon electrode and you release CO2 and carbon monoxide. When we go to ceramic electrodes, which is already in trial on the Earth, then the only thing that comes out of that process will be oxygen. So that's kind of the same process that looking to do it. Very, very early stages. I mean, this is really stuff that we're still talking about how we're going to do that. So that's just a little feel for some of the technologies in using the resources on the surface of the Moon and Mars. Absolutely critical if we're going to live and work off our planet. Just to give you a little bit of a teaser, I wanted to give you a teaser on some of the fantastic geology that is going to come in the next few decades in our solar system. So as we look at Europa is the moon of Jupiter, and it was really exciting to see that the discovery of oceans and basically liquid oceans beneath the ice surface of Jupiter. And so these sort of ocean worlds, we've got Enceladus as well, but Europa offers this opportunity to explore an ocean world. One of the first missions, which is planned, let me just share with you what we kind of know about Europa. So, think possibly a metallic core there, rocky center. This looks sort of familiar, if you like, from Earth, but a very, very thick ice covering, and then below that, so the ice covering can be 7 to 10 kilometers, that ice covering there on the right, and below that, an ocean. So these ocean worlds are extremely interesting because of the the tides themselves. All sorts of interesting things will come out of this. So the plans at the moment to explore Europa are Europa Clipper mission in the next few years, which will orbit, map, and hoping to map some of these plumes as well that we think are on Europa, starting to understand the heat transfer, the geological processes on the surface. You see those fantastic striae and on Europa. So trying to understand all of that a bit more. And then there's a Europa lander mission proposed, not yet has a time, but to get on the surface. And then a really exciting mission, which is the Europa triple mission. Possibly couldn't really launch before 2030, and it will look at penetrating the ice layer, and then going below that ice layer to explore the ocean. So that's just a bit of a teaser, really, to give you a sense of some of the really exciting geology that's happening off our planet, and really to share with you that the early plans of Australia joining the US and the other international partners on the return to the Moon and Mars are actually progressing pretty quickly. So let me stop there. Really appreciate the chance to share a bit of off-Earth geology and technology and some of the plans of the Australian Space Agency. So back to you.